Hello everyone, I'm Zheng Junyi. Today I'm going to share a research example about the urban landscape ecology with you. I hope you will get a better understanding about urban landscape ecology's research content, methodology, and paradigm after listening my presentation. And I will try my best to make it easy for all of you. So the paper I want to share with you, titled with Assessing Spatial Temporal Dynamics of Urban Expansion, Vegetation Greenness, and Photosynthesis in Megacity Shanghai, China during 2000 to 2016. I will follow this order to give the presentation. The first part is introduction. Vegetation plays an essential role in urban landscape, such as reduce air pollution and effect of urban heat islands, increase terrestrial carbon storage, and stress relief and increase property value. However, rapid urbanization has exerted complicated influence on vegetation conditions, which remain poorly understood. To date, most of previous studies reported the effect of urbanization on urban vegetation in the context of single vegetation variable over selected years. In order to have a thorough ecological valuation of urban ecosystems, it is necessary to quantify the changes of two or more vegetation variables over multiple years. To assess the impacts of urbanization on the vegetation structure and function in the urban area, the researchers quantified the changes in impervious surface areas and assess the impacts of urbanization on vegetation greenness, EVI, and gross primary production GPP in megacity Shanghai. The researchers aim to investigate the process and patterns of urban expansion and the spatial temporal dynamics of impervious surface coverage, EVI and GPP, and the impact of urbanization on EVI and GPP along the ISC gradient. The second part is materials and methods. Shanghai has gradually developed into the largest and the most prosperous metropolis in China, accompanied by an increasing acceleration of urbanization. The study area is Shanghai City. Shanghai is divided into 16 country-level districts, which include core urban area and peri-urban and rural areas. And in the Landsat imagery and pre-processing, all available standard lateral van products of the Landsat surface reflectance images on the Google Earth Engine platform were used in this research, and two greenness-related spectral indices, NDVI and EVI, and two water-related spectral indices, LSWI and MNDWI, also used in this research. And using the indices, Landsat images were classified into three broad land cover types. The first is open surface water bodies, and the second is impervious surface, and the last is the other land cover types and or unclassified. What's more, the MODIS data and GPP dataset were also used in this research. The researchers used the linear regression models to analyze the trends and relationships between EVI, GPP, and ISC, and used the framework to quantify the direct and indirect impact of urbanization on vegetation growth. The third part is the result. Figure 3 is about the spatial distribution of impervious surface in Shanghai, and C is expansion, D is annual dynamics of IS in Shanghai. So by the way, the impervious surface is a key indicator representing the process and the pattern of urban expansion. From the figure 3C, we can see the direction of urban expansion is spreading around the core urban area, peri-urban and main road. And from the figure 3D, the urban expansion shows a gradual slowdown trend which can be divided into 3 periods. And the IS areas doubled from 2000 to 2016. The figure 4 is about the trends of ISC, EVI, and GPP. The ISC showed a significant increase trend in most regions, which was consistent with the urbanization. And the vegetation index and GPP showed a significant downward trend in most regions, which is easily understandable that urbanization limits vegetation growth conditions. Surprisingly, a fair amount of grid cells with significant increase in GPP trends were found in the urban core area, which means urbanization can contribute to greenness and GPP. Based on the model proposed to quantify the impacts of urbanization on vegetation growth, we can also clearly see the positive impact of urbanization on vegetation greenness and GPP. Based on the model, the researchers quantified the impact of urbanization on EVI and GPP along the ISC gradient. We can see the ISC values of 0.2 seems to be a threshold value, where the indirect impacts began to appear. The absolute change of EVI and MPP then increased and peaked at ISC values of about 0.8, which compensated for the vegetation loss, and the compensation was more stable and significant in peri-urban area than urban and rural areas. So we can draw a conclusion that during the city expansion, massive vegetation and carbon loss caused by the land use conversion in peri-urban and rural areas. However, in middle-high urbanized areas, urban environment and human management can improve the condition of vegetation, which may compensate for vegetation loss caused by urbanization. And this research also highlights the advantage of advanced technology such as Google Earth Engine, pixel and phenology-based land cover mapping algorithms, and data-driven model in urban landscape ecology research.